Hey everyone, so today we're going to start with this lecture on Introduction to Complex Numbers. The previous lecture was just about the introduction to the course. This is the formal introduction to the course. Well, this is where we start with the math. So we're going to start, like I told you in the syllabus in the previous lecture, that we're going to start with the complex numbers. So in the beginning, I would just like to do a little bit of recap as to what we studied in the previous courses. There are many types of numbers, but for this course we'll only be using two categories of numbers, and one is the real numbers and the other one are the complex numbers. Now when I say real numbers, I also mean rational and irrational numbers, because for the sake of this topic we're going to consider only two types of numbers, that is real numbers and complex numbers. Even if you look at the definition of real numbers on Wikipedia or any other online resource, you'll see that they say that the real number is any number that can be represented on a number line. But there are some numbers such as the pi or the under root of 2 that cannot be represented on a number line. However, they are also treated as real numbers. Inside the real numbers, there is also another way to differentiate numbers, that is the rational numbers and the irrational numbers. The reason why I'm not explaining to you with the help of any math right now is because this is just a recap as to the stuff that has already been taught. So this is just to explain the next concept, that is of the complex numbers. So rational numbers are all those numbers that could be explained, that could be brought down into a ratio of integers. For example, 10 is a rational number because it can be explained as written down as 10 by 1 or by 20 by 2. And on the other hand, the irrational numbers would then be the numbers that cannot be explained or cannot be written down or simplified in the form of any ratio such as pi. Yep, now pi is an irrational number, and under root 2 is also an irrational number. Now as for the other types of numbers, these are complex and imaginary numbers. Now don't get confused when I call it complex and imaginary, because the thing is that these words are used interchangeably. Complex numbers are the real name that we're going to be using for this course, and imaginary is just a part of the complex numbers. Of course, don't get confused by what I'm saying right now. I will go through all of this step by step and explain all of this in quite some detail, so that this concept is really easy for you to understand. Moving on. So I would like to talk first of all about square roots. Square roots, we all know how to solve square roots. We basically find the perfect square of any number, or if there are decimal numbers, we try to use a calculator, or we can also find that through a lengthy process. But if you look over here, that we know that the under root of 16 is 4, and the reason for that is that if we square 4, we will get 16. Just like that, the under root of 25 is 5, and the reason for that is that if you square 5, we get 25. And just like that, you can do the under root of 4, which is 2, and the reason for that is if 2 square is equals to 4. We can find the under root of any number. These are 16, 25 are called perfect squares because they have an answer which is a real number, which is an integer and not a decimal number. So these are called perfect squares, but we don't have to get into that. This is that is not relevant to the topic right now. So right now I'll be telling you why there is a need for complex numbers. There are two reasons for that. One is the reason, basically they're both connected, and now for that reason I would like you to ask the question. I don't know if you have seen this or not before, but what if there is, other than this under root 16 and under root 25, what if there's a negative integer inside the under root? What if rather than under root 16 there is negative under root of negative 16? What then? How are we going to find this answer to that? Because we all know that if we square the negative of any number, it becomes positive. So if you look at like 16 over here, we know the answer to that is 4. But on the other hand, over here it's negative 16. The answer of that can never be minus 4, because if we write minus 4 square, that will become 16. So that won't serve our problem. That won't be the solution to our problem, because we're trying to find the under root of negative 16, not the under root of 16. We know the under root of 16 is 4, but the under root of negative 16 has to be something different than that, and it cannot be minus 4, because if we square 4 we get 16, and if we square negative 4 we once again get 16. So in order to get this, we know that since the answer to my negative 4 square is also 16, which could be written over here as well, this problem will have some other solution. The under root of negative 16 has to be solved by some other way. And you would be surprised that before the 17th century there was no issue regarding to this, because the mathematicians and the scientists of that time did not have any solution to this. So they had to find some way in which they can find the under root of negative numbers, because we cannot get a negative number by squaring a negative number. You cannot get the answer to under root 9 by squaring a negative 3. So negative 3 would give you 9 once again. So in order to find the under root of negative 9, we need to come up with a new method in order to solve this problem. So for that purpose we basically introduce complex numbers. Now I'll explain complex numbers to you with the help of an example. Let's say we take the example that we used in the previous slide, that is under root of minus 9, negative 9. Now in order to find the under root of negative 9, we know that it cannot be, C over here represents basically any real number, and we know that the square of any real number will give you a positive number. So, and there's no way that we can find the under root of negative 9. There's no real number that will give us the under root of negative 9. For that reason we have to come up with complex numbers. So in order to represent complex numbers, this little guy over here, that is the I, was introduced. Now the reason why it is called I is because it is an imaginary number. Look at it in this way, that 1 is a real number and I will be used with every other imaginary part. So there's real and imaginary. Now a complex number is any number that will have imaginary part in it. I will explain to you that there are numbers which have no real part but still are complex numbers, and then there are complex numbers which have a real and an imaginary part. So you have to remember that every number there are two types of number right now that you have to keep in mind. One is the real number and one is the imaginary number. And complex numbers are those numbers that have an imaginary unit inside of them. Now what basically is I? I basically will give you this, that is, if there's an I, if there is an I with the number, it will give you a negative number if it is squared. For example, if there is 4i, then this will give you negative 4, and the reason for that is because of this, that the square. So now we know that there is a solution to the problem that we were facing of finding the square root of negative 9, and the solution to that problem is I. What does I do? Once again, let's look at another problem over here. So what happens is, basically in the most basic form is this, that first you do the first you look at the question. Now let's just say the question is under root of negative 9, like it is shown in the slide over here. Now you try to find the answer. You know that there's no way that you can find a real answer to this question, because the real answer would end up in a positive number. Now but inside the square root there is a negative number, so we need a complex answer to this question. In order to get a complex answer, we know there has to be this imaginary unit I inside it, because only if I is squared we can get an answer in negative. So in order to find minus 9, we with the help of a square, so we know now that minus 9 could be the answer would be 3i squared. So 3i squared, as you can see over here, will give you basically this will provide you with the answer, and that would be 3 and then multiplied by 3. Basically is a product will be given, multiplication will be done between 3 and whatever is I square. Now we see over here that I square is equals to -1. So if we break this equation down, it will be 3, and then over here we will get -1, and then we can get the answer to our original question, that is the under root of -9, and the under root of -9 will be 3i square, because if you break it down it will become 3 multiplied by -1, and that will give us the answer, that is -9. So you have to remember this, that we already know this rule, that the square of any two real numbers is basically positive. So when we have a negative inside a square root, we need to have I square to be precise, so that we can get this number in -1 inside us. So basically this over here, let me correct this for you. This will be like this. Like this will be the square of all of this expression. So if we have 3i square, we would get 9, and then over here we will get -1, because I square is -1, as you can see over here that I square is -1. Once this is done, we can get the answer to our question, which is -9. I will explain to you, let me explain to you with the help of another example. What if we have to find the answer to the question, the under root of -25? Now, as we know already that there is no solution to this inside in the case of real numbers, so we know that the 25 we can get with the help of 5 square, but we also need a negative for this. So in order to solve this question, we need to come up with a complex expression that has an imaginary part. So this can be written down as 5i square, because since we need a negative answer to this, we will have the I square inside of the I square instead of just 5. So this can be broken down into 25 into the negative of 1, because this is 25 would be, if we simplify this, we will get 5 square, which will be 25, and then we have I square over here, which will be -1, as we can see over here. So the answer would now be 25. Therefore the answer to this question, that is of -25, would be 5i. Now I hope you get the point of all of this. We have to forget this one right now. So the answer to this question is -25. Under root of -25 will be 5i, and the reason for that is because 25 under root of 25 is 5, and since it is a negative number, we have to add the I over here, so that if both of these are squared, like 5i whole square, so we get 25 as our answer. It is pretty much a simple, really a simple concept. All we have to get through our head is that whenever there is a negative inside a square root, like there is a negative inside a square root over here, as you can see in this under root of 9, there will be a imaginary part to the answer, because this is this basically means that now under root of -9 will be a complex number, and a complex number basically has an imaginary part in it, and an imaginary part is represented as I. So I square is -1. This is the point where you have to realize that the answer to this is pretty much straightforward, because if you were to have under root of 9, you would have the answer would be 3. In order to add this negative sign over here, we use I square, which will come out to be -1, and under root of -9 would then be 3i, just like the under root of -9 would be 3, under root of -9 beg your pardon, under root of 9 would be 3, the under root of -9 would be 3i, the under root of 25 would be 5, the under root of -25 would be 5i. So thank you very much for watching this lecture. I will continue with complex numbers in the next one. See you there.